an exoskeleton. And Russ, maybe you could explain to me what it is that I'm wearing.
Sure. Thanks, Daniel, for being brave enough to try it on. So Daniel's wearing the Exo vest. It's the first time he's put it on, and we're going to demonstrate what it does in front of you for the first time. So it's geared for manufacturer workers, construction workers, anyone that spends a lot of time with their hands overhead. And so I'm going to give you my backpack. It weighs about, I don't know, 15, 20 pounds. Okay. So try lifting that up.
It's heavy and nearly impossible.
You wouldn't want to do that all day, right?
Nope.
All right, so now I'll turn it on. Now lift it up.
Much lighter, yeah.
Much lighter.
Yep.
So that's it. It doesn't give you superhuman strength. It's really about endurance, all day endurance. And you could just hang out, wave, your next parade, you're good to go.
Right.
So that's it. So bring your arms down. I'll shut it off and take it off you. We can get to the panel. And just take it off like a backpack. It's also the first time you've had anyone in a sports coat in it.
Nice. Well, okay, so you've seen the demo. Maybe Russ, you could start off by just saying a little bit more about what Eksobionics is and what exoskeletons are and who they help, but how they do that.
Sure. So Eksobionics, we're all about helping people. We started as a DARPA program back in 2000. The company was founded in 2005. We made advanced technology to try to augment soldiers' capability, protect them from injury. And then we got into the medical space, which we now sell medical exoskeletons around the world for rehabilitation from spinal cord injury or stroke. We've helped over 6,000 users take over 77 million steps in our devices. And now we're getting into the construction and industrial space, again, trying to help those workers that are spending all day on the job, tearing up their shoulders, their backs. How do we provide them with technology that's actually going to help them do their job safer, more productively, and longer?
Got it. Rosanna, maybe you could talk about what Carbon is and what
Yes.
you're doing.
So we are Carbon Robotics. We build intelligent, low-cost robotic arms for light industrial manufacturing primarily. So today, if you want to automate a task, it's easily tens of thousands of dollars just to buy the arm, and that's only about 25% of the total cost. There's a ton of peripheral hardware that goes along with it, and then on top of that, the programming is really expensive. So it can cost 2 to 3 times as much as the arm itself to actually program. And so in manufacturing today, 90% of all of the tasks that could be automated are being done by hand. And these are things like scraping metal off of parts and putting boards into jigs, things that people do for hours and hours, repetitive tasks that's the problem we tried to solve. So our arm is about 10 times cheaper, has industrial grade precision, and it's simple enough for anyone to set up. So now the people who have the tasks that they want to automate are able to actually do that rather than hiring in contractors.
So the idea of an inexpensive robotic arm, like how big of a game changer is that?
This is huge. This actually, I remember reading an article a few years ago before we'd even started. SRI had said that this was $5,000 as a mark was the tipping point for getting robots into way more applications. So it's partially the cost of the hardware, it's also the ease of use, but really anywhere that we're seeing people doing the same things over and over again, and then not retaining any of that intelligence, and people are having issues with rising wages. In many cases, they can't hire the people that they need, and in a lot of cases, these aren't the roles that people really want to be doing. So it's huge. Right.
So this word democratizing robotics is being bandied about. Like, what does that really mean? Like, what do you like? How?
I think it's just awareness and acceptability. So making this technology available to folks. So I totally agree. Getting the price down, that makes it more attractive to a wider audience of users to actually start implementing. And then it also, what we've seen with the construction side is by having the augmentation technology now, it doesn't have to be that 250-pound worker doing the job with a heavy tool. You can actually democratize the workforce and actually have someone that weighs 120 pounds doing that same job. Mm-hmm. So it actually opens up a lot of opportunities for different workers.
Does it open up new industries altogether, you think?
I don't know. That's an interesting one, like servicing robots. I think it's all out there. I think it's going to change the way people think about work, and it's going to help people that are in the workforce now either work longer because they have to either retire later. They can work longer without getting hurt, but hopefully this technology also helps attract people into these jobs, realizing that there is cool technology they can leverage now. It's not the same old type of work that's going on.
And do you think inexpensive robotic arms will also, or can also, open up new industries?
Oh, it's huge, yeah. I mean, so we started with the industry that we started with because there's such a high pain. So there's a high need to automate, high desire, and huge pain when they don't automate. So this was a good place for us to start. But we have people reaching out all the time from different industries. So, for instance, pipetting in labs. A lot of that is manual. It's grad student labor. It's people dispensing liquid and doing that for days and days and days. And but behind the scenes, what we're building for one application is actually very similar for that. It's basically moving between positions and being able to perform work that, even though it looks like it's a completely different industry, really behind the scenes it's very similar. So it really is changing how we think about labor.
Right. How do you raise awareness for what both of your companies are doing?
How do you raise awareness?
Yeah.
So we make fun robot videos. That always helps. We're going to be launching some new ones as well. I think a lot of it is teaching people what can be done with tools that they don't necessarily think about. So for us, a lot of it is going into customer sites and showing them something that they had no idea they could use robotic tools for, showing them that they can do that and just how easy it is to set up. And I think that so a lot of our work is really just broadening their horizons of what's possible.
Yeah, it's definitely a challenge raising awareness. We've been fortunate with the medical side that when someone's wearing a medical exoskeleton that's been paralyzed for 20 years and stands up and walks, we get a lot of media attention, so that actually helped raise the awareness on the construction side. But now getting out to those end users and letting them know that this technology is not science fiction anymore, that it's available, they could go rent it today, that's really a challenge. So the awareness coupled with adoption, I think you have to, again, being price sensitive, have the right channel. We go through the rental channel, making it very easy, right? It's $30 a day to get this technology, so it's really easy for them to adopt. But now we have to explain to them how it's available or get the word out, which we do through different conferences and stuff, but it's a challenge.
So there's been a lot of talk over the last few years about robots are going to come and take our jobs. Like, I don't personally think that's true. What do you guys think?
I think that it's a really important conversation to have, because we are starting to see what we think of as being work is changing. When we look at the tasks that we help automate, these are things that really, one, in many cases, they're having a hard time finding people to do those tasks. One of our pilot customers is already unable to staff sufficiently. They're paying 2 times minimum wage, and they have a huge rate of people just leaving the company. And so that's something that is very frustrating for them to deal with. But I think in many cases, these are tasks that people don't want to do, and that no human should have to do. So I've spent a lot of time in factories, a lot of time. And these are things that, in many cases, if you wouldn't want to do them and you wouldn't want somebody you love to do them, then it changes how you think about it.
Yeah, for us, it's a little different. We definitely need a human for any of our technology to work. So it's more of a hybrid solution. And what we look for in applications is the highly skilled, high decision-making type of task that's in a very unstructured environment. So think a construction site where it's constantly changing. Those are the tasks we go after, and what we found is by doing that, you can take that skilled worker that has 30 years of knowledge in doing this job, and now give him mechanical assistance to do that job without the pain, to let him do it longer versus having to go take a desk job for the rest of his career because he's blown his shoulder out and hurt. So it really helps keep those guys on the job, working longer.
I think it's really the fusion too. It's letting robots do what they're good at and letting people do what they're good at.
Right.
The tools should amplify what it means to be human.
Right. But I would imagine for people that have been, doing the same type of work for decades, even, that there's some sort of entrenched mentality of how things are supposed to work. So how hard is it to get those guys to try it on and change?
That was a really interesting insight we had when we went out to customers and started demoing it. The older workers that had been through either a shoulder injury or been hurt before, they were the ones that were most likely to come use it, because anything that could make their life better to where they could go home and throw a ball with their kid at the end of the day, they were all in. The younger workers, there was a little bit of machismo. They're like, I don't really need it. I'm strong enough. Then after they use it for a while and we shut it off, they're like, no.
They don't want to go back.
We want to use that.
Nice. So, when you're getting ready to go into the office every day, like what is the sort of the biggest concern that you have? Like, how am I going to move my business forward? Like, what are the biggest challenges?
Yeah. For us, it's awareness and adoption. Like letting people know, like, look, the stuff's here. It's only going to get better. There's tons of applications for it today, and where we're going is, more sophisticated types of exoskeletons. The ones that are out in the market right now are passive. They're very simple. They solve real problems. But it's that strategy to actually get them to adopt the technology, that crawl, walk, run strategy. That's key to getting the acceptance and getting it out there.
Right.
I think for us, we are very focused on our pilots right now and getting those initial applications. But what I'm most excited by and think about a lot is what happens when you bring these tools to people who can develop applications for them in other industries. So I think one of the things that's really cool about what you guys have done is that you've seen this tool that can be used really for just amplifying humans, be it construction, be it a different industry. And there's such an opportunity to get these tools out to people. So what I think a lot about is, well, how do we make it so that we're not the only ones developing the applications, and we're not the only ones creating this, and we're not the bottleneck. So we spend a lot of time thinking about how do we build the infrastructure so that we build application 1, 2, and 3, but somebody who doesn't know anything about robots but really knows their application and really knows how to program could then take that and apply it to something else.
So it's a classic case of sort of emergent behavior, like seeing people doing things that you didn't expect.
Yes.
Can you talk about any of the things that you've seen people do that surprised you?
So we get a lot of outreach from industries like I mentioned, but we get some off the wall ones too. So there was one that snake venom extraction is apparently a big problem.
What is it?
Snake venom extraction. We've units that go out. Most of our units go to pilot customers. Some go to developers, and it's like, hey, what's your idea? What's your application? And that was one of them. We get a lot of very artistic applications, so people putting cameras on them and being able to do really cool motion control because it's a precision tool. And so that for us is fantastic. We love hearing those stories, seeing what people do.
Yeah, for us, we got a picture sent to us one day, and the guy had, typically on our 0G arm, people mount heavy rivet busters, chipping hammers, or rotary hammers. And he sent us a picture with a concrete chainsaw strapped to the arm to cut open some windows, which, one, I didn't know there was a concrete chainsaw, which is kind of cool. But two, seeing him adapt the arm to work for his setting was pretty neat. Right,
so it must be, those are the kinds of stories that get you excited to go to work every day?
Yeah, no, you want to, having a job where the whole mission really is to make people's lives better, right, and help them out. And when we showed up, I'll give you this, we were up on the Tesla battery factory drilling holes in the ceiling, and with the use of the arm, that guy went from drilling 80 holes a day to over 400 holes a day. And when we showed up on the factory to kind of get his feedback, he was literally like, are you the Exo guys? I love you. I love you guys, because it's making his life that much better.
Right. What are the biggest sort of design challenges that you face when you're developing the products? Like, what do you have to think about the most to make sure that it works well with people and it works well for the company's needs and things like that?
So we spent a lot of time just figuring out how we could bring the cost of the hardware down to get it just to even have a company. And so to do that, we had to go pretty deep with the supply chain and figure out ways to make our own motor drivers. And so that was sort of a lot of work that we had to do just to get to the point where we had an arm that had the goals that we wanted to hit, but at the price point that we could achieve. And now a lot of our attention is on how do we make it collaborative, as safe as needs to be. So one of the big problems in robotic arms today is that they're not very safe. Even collaborative robots generally have to hit you to know where you are. So people will put vision systems on them, or they'll slow them way down, so they're running at about 10% of their rated speed. But if you take that to a manufacturer who says, well, I really care about throughput because I need to hit a certain ROI, there's a huge gap there. And so we created a new sensor that is actually built into the housing of the arm that can detect motion up to 20 inches away in any direction from anywhere on the arm. And that's something that is a different way of thinking about safety, but it's also taking steps to make sure that those collisions never actually happen.
Right. And how hard is it to get the lawyers, to sign off on that? Like the idea of getting people and robots to work so close together.
You have to do a lot of testing and a lot of certification and a lot of. We're very cautious and like to make sure that we test in-house before we ever go out.
Right. And then your design challenges, maybe?
For us, probably the biggest challenge is no human is the same size, right? And so when you start putting technology on them, it has to be comfortable. You have to be able to wear it all day. It can't be hot. It's got to be light. I agree with you. Cost is a huge component. So you take all of that into account. And if you think about like the end state where it's going, like we're all wearing exoskeletons. Everyone in the audience says it's your clothes, right? And nobody's wearing the same size. But for some reason, when you start with some sort of exoskeleton, they want a one size fits all. So if everybody here was wearing one size fits all pants, I think we'd look pretty silly. So how do we get there in a reasonable way and make it comfortable for every user? That's a challenge.
Going back to the idea of like inexpensive robotic arms, like why is now the time where that's happening? Like, what's happening right now that's making that possible?
I mean, one of the big things is having just faster processes, being able to actually run very fast algorithms on the device in ways that wasn't possible before. In some ways, we benefit from tangential markets as well. So we use a lot of carbon fiber, which became very inexpensive because drones took off. And so we're able to leverage that. And also washing machines. So there's been a lot of innovation with motors for washing machines, smart washing machines.
How does that work?
Well, they have a variable load, and so a lot of the things that you need to make that successful, you need in our application as well. So it's finding these different tangential markets and seeing where they've made innovations, and then elegantly stuffing them into a robot.
Right. Are there a lot of exoskeleton competitors, and if so, like how do you differentiate what you're doing from those?
Yeah,
people?
no, that's a good question. There is. I mean, we had the world's first untethered powered exoskeleton back in 2004. I think we're in the world records for that. That was, again, the DARPA project. But since then, I think we've gone through that technology tipping point that's enabling your robots to work as well and be cost effective. We have better processors, we have better sensors, we have lighter materials. All those things have fed this exoskeleton market as well. So there's competitors across the board, other people working in medical space, other people working in the industrial space. Some people are dabbling in the consumer. It's not really there yet. But I think what differentiates us is we do a little bit in all of those spaces. And it's really interesting. I go back to our exoskeletons we made for soldiers. One of the requirements there was make sure the guy can get in and out of it very quickly.
Right.
And then we incorporated that feature set into our rehabilitation exo just because that's what we had done for that exo, which turns out to be a huge win because when a hospital buys a medical exo, they want to hit 8 to 10 patients per day and get them in and out of it very quickly and resize it. So there's some benefits to having that kind of high-level vision of the whole market.
Nice. Well, I think we're out of time. The clock just hit 0. So
All
thank you
right.
very much
Thank you.
for
Thank you.
talking with me. Thanks for coming.
Thank you guys.